Hey guys, I hope that I'm live right now. If you guys are able to listen me properly as well as there's no issues with the audio or the video, please let me know. Yes, I know I look like a floating head because by mistake I've worn green today. I didn't realize that. So I look like that character from what was that? In that there was a lion, the tin can man, the girl. What was that character? I don't remember it. Do you guys remember which was that particular character? The moving head, the Wizard of Oz, right? The Wizard of Oz. I'm from that itself, right? Wizard of Oz. I'm just a floating head right over here. Okay, so how are you guys? Is everybody fine? Good, great, amazing. What is the scenario? How are you guys? Is everybody fine? Good, great, amazing. What is the scenario, guys? Yeah, Wizard of Oz, right? I'm from that. Okay, so good, must, amazing, fine. Oh, why fine? Why not great? Why not better than before? Right? Zabardast. Okay, bro selected the wrong dress today. The wrong T-shirt. That would be nice. Not a dress. Again, not a cross dresser. Okay, no issues in that, guys. So yesterday we had dealt with some of the basic theoretical things. Today we are going to dive into the practical things today, right? We are going to start off by creating our very first simple ANN model itself. That is what we're going to do today. So are you guys ready for that? Please let me know. Are you guys ready for the same? Please let me know, guys. Are you guys ready for the same, guys? Please let me know. Yes? Okay, great, guys. Awesome, awesome. So let's get started, guys. Let's get started. Please do remember today the project that we are going to do, it is going to be a pretty long project, guys. Okay, so please do remember that it is going to be a pretty long project. So it is going to take us some time. I will reduce the time limit by not training the algorithm way too much. So I'll be reducing some of the things. I will be letting you guys know how you guys can improve the algorithm. So you don't have to worry about that because we are on a time constraint, right? We cannot have our AI reading the same data set for like 1 hour. We have to do it in 5 minutes. So we'll make some changes, guys. I'll tell you guys what changes I have made so that you guys can correct it. So let me present the screen first of all. So share screen, entire screen share. So I think so you guys should be able to see my screen and my floating head both at the same time, right? You guys should be able to see my screen and the floating head at the same time. Should I put it up like this? This looks better than the previous version, right? The video on the right hand side. It looks as if I'm looking at the screen itself. Otherwise, it looks as if I'm going against the screen. But this actually puts it up in the way of our coding, so that is not good. So let's keep it like the previous version itself. Okay, so we are going to use Colab. So you guys can just search for Colab on Google, and you will get the first particular link. Okay, Google Colab right over here. Just click on that, guys. You have brought in your notebook and your pen, right? It's you guys remember that. Notebook and your pen, you guys remember it or have you guys forgotten about it, guys? You guys remember that, right? Okay, great. So what is our aim? Okay, our aim, where is my screen? Okay, this is what I have to open it up. So our aim is going to be pretty simple, guys. We want to create an AI that is able to predict something that we already know. So usually what will happen is you don't know something and you want your AI to predict something that, okay, is it going to rain today or not? You don't know that, right? So you want AI to predict it that, okay, when it was 32 degrees Celsius, when it was, the humidity was something, I was in Bangalore itself, it rained today, okay, rain happened today. So you knew that. And accordingly you want to predict that, okay, tomorrow it is going to be 34 degrees Celsius, this is going to be the humidity, I'm going to be in Bangalore, is it going to rain or not, right? So you don't know if this is going to be true or not, whether the AI is going to predict something that is right or wrong, you don't know that, right? So today we will be going into a different direction. Today I'm going to take up an equation, guys. I'm going to take up a very similar equation from our yesterday's class, that is y is equals to x square. Okay, y is equals to x square, guys. That is going to be my equation. I'm going to provide my AI these values, that is x and y values itself, that is x is then 1, then y is also 1, x is 2, y is equals to 4, x is 3, y is equals to 6, x is 4, y is equals to 16, and so on and so forth. Okay, this is what I'm going to do. Okay, I'm going to provide it with different values, not 6, okay, that is 9, 16, 5, then 25, 6, then 36, 7, then 49, 8, then 64, 9, then 81, and so on and so forth. I'm going to provide my AI with these values. I'm not going to tell him what is the equation, right? I'm just going to provide him the values, and he has to figure it out, or it has to figure it out, that okay, the equation is y is equals to x square, and he has to predict the right particular answers for the future data points that I'm going to give him. Okay, so that is going to be the aim of today's class. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Are you guys able to understand this, guys? Please let me know. Yes. Okay, great, awesome. The next thing that we're going to do right now is that we are going to understand a few more terminologies itself that we're going to use. For example, NumPy and Keras. These are some new terms that you will be learning of in our today's class, guys, NumPy and Keras. So please try to understand, Python is just a programming language, right? Python is like, how can I make you guys understand? It is like water. Okay, Python is like water right over there. Now, if you want to, this particular water, if you want it to freeze, what do you require? You require a refrigerator that has a freezer. You require ice cube buckets itself, a container to freeze the water in, right? You require multiple different things for that water to freeze. Now, there are two different ways of doing it. First, you can go and buy a refrigerator with a freezer which has a particular ice bucket inside of it, and just pour in the water, and voila, you have got ice with you. The second particular way of doing it is sit at your home, create an entire big refrigerator with a freezer on your own itself. Now, what would you do? Would you sit and create that entire freezer on your own, or would you just purchase it from like Samsung or LG or whatever, Whirlpool or whatever company that you want to get the particular refrigerator from? What would you guys do? Please let me know. You'll go and purchase it, right? Because sitting there creating the entire thing from scratch means you are wasting your time at the end of the day. Many of the times you will be like, you don't even know how to create a refrigerator, so you will be way too engrossed in like, what am I going to do? I'm not able to understand anything, right? So the similar way for Python as well, it is a programming language that can do a lot of different things. A lot of different things, guys. But the problem with Python is that what you want to do is going to be very complicated. So what if there was somebody who was very brilliant, very amazing, who created an entire refrigerator for you that you can directly utilize, and then you just need water, you just need Python, you just do something with Python and you get the results directly. That is the concept of libraries. My spelling is very bad. That is the concept of libraries, guys. What do libraries do? For example, you want to work with array-based data. You guys know array, right? You guys have studied arrays in your school days as well. A collection of numbers, right? A collection of numbers you want to do, right? So you want to deal with array-based data, or you want to deal with matrix multiplication, not arrays, matrix. You guys have learned about matrices and matrix in your 11th and 12th, I think so 10th standard, right? Matrix multiplication, matrix division, transformation of matrices itself. You guys have learned that in your school days. Do you guys remember it, right? 11th standard, if I'm not wrong. Right, guys, you have learned about matrices, right? So you want to deal with matrices in Python, then you don't want to create an entire thing that holds the particular matrices in place. You don't want to create a particular algorithm that is able to do that multiplication of matrices very fast. You will have to code it from scratch. So there is a particular like library that has already been created called as NumPy, which helps you dealing with these matrices very well. It comes up with all the different things that you you need to create matrices, to use matrices, to perform operations on matrices very, very, very fast. If you try to implement a particular idea of a matrix inside of Python directly yourself without using the library, it will be more than 10,000 times slower than what you will be able to do by using directly the NumPy package. That is the benefit of using libraries. It is fast, it is efficient, it reduces your code by a lot. It provides you with all the tools that you require to do a certain task. So one of these, so there is matrix and there is matrices. There's a difference between the two. Matrix, multiplication, matrices. Okay, these are like singular and plural in nature. So if you guys don't know, matrix is basically a single matrix, and matrices is basically multiple matrix that are there when you deal with multiple matrix that is there, right? So matrix, I'm very sorry, my pronunciation is not that right, but yeah, I hope so that you guys are able to understand it, right? So NumPy basically helps you deal with these matrix multiplication and matrices and the particular operations that you want to perform in that. So that is one of the libraries that we are going to use in this particular bootcamp. Now you guys might have heard about TensorFlow. Do you guys remember TensorFlow, guys? Do you guys remember TensorFlow? Or have you guys forgotten about it? Yes? So TensorFlow is again a library itself that has been created by Google to help you do like for example, to help you make machine learning algorithms much more faster. You don't have to do all the mathematical computations and everything. Everything has already been done for you in a highly optimized manner itself according to the latest research that is going on, so that you don't have to focus upon creating the machine learning algorithm. You have to focus upon how to utilize that machine learning algorithm. Are you guys able to understand this? Please let me know. It includes both machine learning and deep learning algorithms. That is the reason why I'm saying machine learning algorithms, not just deep learning algorithms. Okay, so machine learning algorithms, to use it, you're having TensorFlow right over here. But TensorFlow is like a fighter jet. Okay, TensorFlow is like a fighter jet, guys. It is like a fighter jet. What is a fighter jet? So if I want to travel from my house in Bangalore, so let's assume that I live in BTM layout, okay, and I have to go to Koramangala, that is somewhere around 5 kilometers away. Okay, I have to go 5 kilometers away itself. Would I use a fighter jet to go there? Would I use a fighter jet to go there, guys? No, right? First of all, fighter jet will have millions of buttons around me. I don't even know how to use those buttons itself. I have no idea how to operate that fighter jet itself. I don't have a runway to fly that fighter jet from Koramangala to BTM layout. Right? So much headache. So complicated system. But I can basically use a fighter jet to go from Koramangala to BTM layout, but that is just a hassle. Okay, I have to learn how to drive a fighter jet, I have to learn how to lift up a fighter jet, I have to find a particular place to go and fly the fighter jet and land the fighter jet. There's so many different things that is going to happen. It is the best. It can run on road as well, it can fly as well, but it is not the right tool to use, right? What is a better tool? A better tool will be a car, right? A car also has tires. A car also helps to transport you from one place to another. Many of the components of the fighter jet, like for example the tires, some of the parts of the engine, if you have a right car or a nice car, it might have some inspiration from the fighter jet as well, right? So just like a car, there is something called as Keras. Again, Keras is also a library of Python that is built on top of TensorFlow. That is built on top of TensorFlow itself, guys. What does Keras tell? That okay, this TensorFlow is very complicated, right? So many buttons, so many different things right over there. You will become confused what to use, what not to use. So let me do one thing for you. I'm just going to bring in the most easiest parts, the parts that you have to use on a daily basis. The rest of the systems, the rest of the controls, you don't have to touch. Okay, you can directly run the entire like fighter jet as a car. Just like a car or a bike, how you ride a bike or how you ride a car, you can ride the fighter jet like that. You don't have to worry about it. You don't have to worry about how to fly it, how to make sure that it is landing. Don't worry about it. Just like the controls of a car itself, I'll put it inside of the fighter jet. You just use those controls to run the fighter jet. Do not worry about all these different buttons. That is what Keras says basically. So for this particular example, for this particular practical project, we are going to use Keras. In the final project, we are going to use TensorFlow, because there we will have to use a lot of different functionalities that comes up with TensorFlow as well. Okay, so Keras is built on top of TensorFlow. Please do remember this. It is not separate. It is built on top of TensorFlow itself. Okay, basically it hides all the different functionalities that you don't have to use right now. That is what it does. Okay, are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Yes, no, what is the scenario right over there, guys? Guys, what is the scenario right over there? Yes, you are able to understand. Very good, very good. Majaidi life. Good, good. Okay, so now we're going to create our new notebook, guys. We are going to create the new notebook. Bro, come on, open up. Okay, we are going to click on the connect button right over here, guys. So it will connect us to the server so that we are able to start writing our code. And then we're going to start with Git. So Python is like just a programming language. We have to tell Python that, bro, we require this NumPy library. Bro, we require this Keras library. Otherwise, we will not be able to use it. Otherwise, we will not be able to use it, guys. So how to do that? You start by importing stuff. Import NumPy. Okay, this is how you import a library. This library already exists. You're telling Python that now I require it. Okay, so get this particular library so that I'm able to use it within my code. I'm going to import NumPy. Now, every time I want to use any functionality of NumPy, I have to write NumPy again and again and again. I don't want to do that. I want to write NumPy. So I want to use a particular tool from NumPy. I will have to write NumPy.toolname. Okay, I don't want to do that again and again. So instead of doing that, I'm going to assign a nickname to NumPy. That, bro, from today NumPy is going to be called as ABC, Andi, Bandi and Sandi. Okay. From today I can assign it any name, but usually by convention you assign a name. So to give it a nickname, you write as and then the nickname, that is NP. So now instead of writing NumPy again and again, I'm just going to write NP. That refers to NumPy itself. I've given a nickname to NumPy right over here. In a similar manner, we're going to import Keras as well. Like I said, we need Keras right over there. So Keras, Keras. And now inside of Keras, there are going to be multiple different, not just tools, but toolboxes that are going to be there. So Keras will have one toolbox to deal with just neurons, one toolbox to deal with just optimization, one toolbox to deal with regularization, one toolbox to deal with model creation itself. And that toolbox will contain, so model toolbox will contain all the different tools required to create a model, to create an AI. The neural particular toolbox will require all the particular tools that is required to create a neural layer itself, and so on and so forth, guys. So we want all those toolbox individually, but we don't want all the tools in those toolbox. I don't want all the tools in that toolbox. I just want some of those tools. Are you guys able to understand it? For example, from the models toolbox, there are different models, right? For example, like I said, there are ANNs, that is artificial neural networks. There are CNNs, that is convolutional neural networks. There are RNNs, that is your recurrent neural networks, and so on and so forth. There are multiple different models that you can create right over there. So let us do this from Keras dot models, models, models. Okay, so from the toolbox inside of Keras, the models toolbox inside of Keras, we want to import just one particular tool. We want to import just one particular tool, that is the sequential tool. I hope so that the spelling is correct. Now, what is the sequential tool? This is basically stating, like yesterday, do you guys saw when I was trying to create a neural network, right? So there was this particular one layer of neurons. Then there was another layer of neurons. Then there was another layer of neurons, and so forth, so on and so forth. This is called a sequential. Okay, this is called a sequential. That is one after the another. There are going to be layers inside of this neural network. Okay, so these are neurons. These circles are nothing else but neurons. This is called as one layer, and this architecture of a model in which you are having layers of neurons one after the other is called as sequential. What is the full form of ANN? Shrishti, you think about it. I've taught it 2 times in our yesterday's class. Think about it. Think about what can be the full form of ANN. Think about it. What can be the full form of ANN? It is not going to be Anna, Nodi and Nitin, right? It needs to be something related to what we are studying. So what can be the full form of ANN? Think. Okay. So right over here, guys, this is called a sequential model. This is called a sequential model, guys. Okay. So we are going to go back. The next particular thing that we want is from the layers. Okay. So from KERA. So now we have decided that the model that we are going to build is the sequential model in which there will be layers of neurons. Now, how are these neurons going to be connected to each other? We need to figure it out. Are you guys able to understand? We have decided that we're going to have a sequential model. That basically means that there are going to be layers of neurons present right over there. Now, how are these, okay? How are these going to be connected to each other? How are the neurons between these layers going to be connected to each other? So from the keras.layers, we need to import dense. We are going to import dense, guys. Now what does dense do? What does dense do? Dense basically means that all the neurons present in one layer will be connected to all the neurons present in the other layer. Basically this means that all the neurons present in the first layer will be connected to all the neurons present in the second layer. Like this. This will be connected to all the neurons. This will be also connected to all the neurons. This will also be connected to all the neurons. This will also get connected to all the neurons. In a similar way, all the neurons present in the second layer will be connected to all the neurons present in the third layer. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. This is called as densely connected layers, okay, or densely connected neurons itself. Okay, this is called as dense layers. Are you guys able to understand this, guys? Again, very simple. These are some of the terminologies that I'm trying to explain it to you guys, right? The next particular thing that is going to be there is optimizers. Now, the concept of optimizers and the concept of some of the other things like regularizers are going to be new to you guys. Okay, so I'm not going to dive a little bit deeper into it because again that there is no point in that, but try to understand about optimizers in such a way that, do you guys remember the curve that we created between the weights and the error of the particular model itself? Do you guys remember the particular graph that we created yesterday between the error and the weights, and we wanted to find the minima of our particular graph? We wanted to find the minima of our graph itself, right? Now to do that as fast as possible, you need an optimizer right over there. You need an optimizer. In the traditional manner, if you do it, your code will be very slow, because you'll have to check for each and every point. You don't want to do that. You want something that is able to accelerate you getting your final answer. So again, that is what we call as an optimizer itself. Here we are going to use the most simple optimizer ever, that is the Adam optimizer. Anytime that you will be learning deep learning properly, you guys will be learning about gradient descent, and there you will be learning about Adam optimizers as well. For right now, you guys can think about it in such a way that we want to find the lowest error possible as fast as possible. Okay, so we need something to optimize the process, and that is the Adam optimizer. Okay, so again from keras.opti, what is the spelling of optimizers? Thank you so much. Import Adam. Okay, so we're going to import Adam as well. Okay, do not make this error like me. Again, remember, Python is a case-sensitive programming language. If you use a small a right over here, it won't work. If it is a capital A, it is a capital A. If it is a capital D, it's a capital D. If it's a capital S, it's a capital S. Always do remember that, okay? I'm so sorry. The next thing that we're going to do is we are going to use from Keras import regularizers. Okay, we're going to bring the entire toolbox right over here. We can bring just the L2 regularizers as well, so you don't have to worry about that. But for this particular purpose, I am bringing in the entire toolbox. It will make the code look a little bit neater. That is my particular scenario. Okay, so now that we have done this, we have got all the different tools that are required to create our model. Okay, so we're going to start creating our model, guys. Okay, you can give your model any name. You can call it as Shaurya, you can call it as AI, you can call it as camera, you can call it as mouse, whatever you guys want to name it as. You can name that as it. Okay, but for the general use case scenario, we call our model as a model. Okay, so model is equals to sequential. We are this is very hard to type it in this particular scenario itself. What is Adam for? Karthik, what did I say? I want you to repeat what I said just 2 minutes ago about the Adam optimizer. What is the meaning of optimizer? Why do we need it? Right, I just said it in just 2 minutes ago. So can Karthik let me know what I have said? Then if you have missed something, you are not able to understand still, then I will explain what is happening. But first you have to repeat what I have said. Okay, so sequential, and then just put up some parentheses right over here. This is how you declare that the current particular model that you are creating is a sequential model, guys. This is where I'm declaring that the current model that I'm creating is the sequential model. Okay, now in the sequential model, you will now be adding the layers that you require. We're going to have 3 layers, only 3 layers, guys. We're going to keep it very simple. We're going to have 3 layers. The input layer, okay, the input layer where the inputs we're going to give, that is the x values. Okay, we're going to have 8 neurons, 1 2 3 4 5 6 7 8. Then we are going to have the hidden layer. Okay, I'm just telling you guys the particular name of the layers. Okay, then we're going to have the hidden layer. It is again going to have 8 neurons, 1 2 3 4 5 6 7 8, and then we're going to have the output neuron, that is 1, because what is the output that we require? That is just y, that is just one particular output, right? We just want the final answer, that is 25 or 16 or whatever the scenario is. So we are going to have just one particular neuron in the output layer. So this is the input layer, guys. This is where you're going to give the inputs, that is the x right over here. Okay, I shouldn't have put it up inside of a circle, maybe a square right over here. Okay, this is the hidden layer. Because why it is called as a hidden layer? Because you don't know what is going on in that particular layer. So we call it as a hidden layer. You know that in the input layer, you're going to provide the inputs, that is the value of x's to your AI. The hidden layer, you don't know what kind of mathematics is going to go on inside of it. So you don't know, we call it as hidden layer. And then the output layer, where you're going to get the value of y. Okay, where you're going to get the value of y right over there, guys. So how to create that? You do model dot add. Okay, in this particular way, you add a layer. Okay, you add a layer to the model. Now you are adding the very first layer to the model, guys. The very first layer, like I said, is going to create with 8 neurons. Okay, we want to add just 8 neurons right over there. We want to add just 8 neurons right over there. Now all the 8 neurons inside of the first layer, what type of activation function do you want to apply? You have to specify that. You guys remember activation function from our previous class, guys? You guys remember the activation function from our previous class? Please let me know. Have you guys forgotten about that? I explained it to you guys in a nice way. Don't forget about it. You remember activation function, guys? Relu, very good. We're going to use the Relu activation function itself, right? So activation function, bro, come on, yeah, activation, and we're going to give the activation as Relu. Okay, we're going to give the activation function as Relu, guys. Now we'll come up to regularizers. Okay, so why are regularizers used? So regularizers, think about it as there are multiple problems that might come to reduce the error. Okay, for example, you might have heard about, or you might have not heard about it. So Google had the best camera ever. Okay, Google Pixel. You guys know Google Pixel, the mobile phone? This mobile phone, do you guys know this? Google Pixel, the best camera in any mobile phone on the planet was Google Pixel. Now, the same camera is used by Vivo as well. Vivo, MI, Oppo, OnePlus, same camera made by Sony. The camera, the hardware is made by Sony. Okay, the same camera is used by every other company itself. Then why does Google has the best quality pictures? Because Google uses AI to tweak that images to give you a better quality image. It tweaks that image to give you a better quality image itself. But a few years ago, almost I think so, it has been somewhere around 7 years, 5 years ago itself that this is what happened. What happened was, because again, they are using AI, that means they have trained it on certain data sets itself. That is the reason why it is giving you that particular higher quality image. It takes in your image, it compares it with all the images that it has learned from. It improves the quality of the image according to that, and it shows the particular new image to you, which is the best image possible after processing, right? So what happened was, when Google was training the AI to do like this, increasing the quality of the image itself, what happened was they used very less black people data. They use very less black people data. They used mostly white people data itself. Now, if any black person was clicking their images, okay, a black colored person was clicking their images, it used to whitewash them. How can I explain whitewash? Basically, it made them look not their natural color. It made them look a little bit whitish in nature. Right now, many people observed this. They put it on Twitter. That time it was Twitter. It was not X, and it blew up. Many class action lawsuits were filed against Alphabet, the parent company of Google, and a lot of shit happened. Google had to recall a lot of those software updates as well. It had to launch a new software update as soon as possible which solved these issues. So what happened was, there was a bias. This is called as a bias. Okay, for example, your teacher might be biased towards a certain community, right? So what happens here was, because there was so little black people data when training the image, training the AI itself, it is not able to work well with black people images. It was able to work well with racially white people image itself. And that is a big problem. Now, to solve these problems, you have something called as regularizers, in which as soon as your Rancho starts becoming like Chatur, as soon as your Rancho, instead of starting to learn from the data, starts to memorize the data, the regularizer will put up a slap on his back. Like, what are you doing? Hey? Learn it properly. Why are you memorizing stuff? That is the rule of regularizers. So instead of your AI being like Rancho and learning everything properly, understanding everything properly, as soon as it starts memorizing stuff, that okay, if it is a white person, do this. If it is any person, just do whitewashing itself right over there. It will apply a slap to his face like, eh, don't do this. Don't memorize stuff. Start learning it, right? So this it does through mathematics itself. I'm not going to go into mathematics. It's called as ridge particular regression, and then you are having some other types of regressions as well. Lasso regression is there. Okay, we are going with the ridge regression. We are not going to go into the mathematics of that, but yeah, that is the basic understanding of regularization. It basically prevents your AI from memorizing stuff. That is what it does. It tries to force the AI through mathematics to learn things properly. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. So if you want to understand the mathematics on all this of like ridge regression or lasso regression, there's L1 and L2 regression, not respectively. Lasso is L1, ridge is L2. You guys can do a Google search and start learning a little bit more about it. But for this particular purpose, for this particular bootcamp, I'm not going to dive into the mathematics of it, because that is another like at least 2 more classes that I'll have to take up to just make you guys understand the mathematics. Because then I'll have to start from the scratch. So I'll apply the L2 regularizer right over here, guys, for our current layer. Okay, so KERNEL. Did I get the spelling? Underscore KERNEL regularizer. I hope so that I've written the right spelling, because it is not showing up. Let me do a Google search. If I made a spelling mistake, it should come up on the Google search itself. I think so I've written the right spelling. Any reason for only 8 neurons? Because our data set is not that big. If you use a lot of neurons right over there, the most likely scenario is that it is not going to work. And always make sure that you are having the number of neurons in a layer in the format of 2 to the power n. Okay, it should always be the number of neurons in a layer, except the output, because that is dependent on how you want the output. But the hidden layer, you should always have it as 2 to the power n. The reason for this is due to trial and error. A lot of people have tried a lot of different things, but when you use 2 to the power n number of neurons in a layer, it is usually faster, it is usually efficient, and gives you better results as well. You can definitely take up 1632 or 1024, but if you take up a lot of neurons and your data set is very small, even though you have used regularization, it will still give you a memorized result. It will not be able to learn anything. Because think about it, you are having a genius and you are providing him with just a storybook, right? He will just memorize it in one go. He will not be able to learn anything from that. That is what is going to happen with that. So always think about how much data you are having. In our case, we are going to generate our own data. It is going to be very small. Okay, so using less number of neurons right over here. For our final project, we'll have a lot of neurons. Okay, so here kernel regularizer, and we're going to use regularizers dot L2. We're going to use the L2 regularizer itself, and for that we need to provide it with a particular unit. So we're going to use 0.001. Now where did this come from? What is this? You don't have to worry about it. The reason for that is, again, we are not going to dive into L2 regularizers. This is something that you have to do, provide it so that it is able to work absolutely well. Okay, then we are going to go further with our input shape. So what is the input that is going to come up to our input layer? Okay, what size of the input will be there? Okay, what will be the shape of our input, right? Again, inputs are going to come as a matrix, right? We are going to have a matrix, a one-dimensional matrix itself, that will be the input to our particular input layer. Okay, so what will be the shape of that matrix? So a one-dimensional matrix basically means that it has number of it has just one particular row, right? You guys know matrices, right? One-dimensional matrix. Do I need to explain it, or you guys know what is a one-dimensional matrix? You guys know one particular matrix, right? What is one-dimensional matrix? I hope so. Yes. So we're going to use the input shape. Okay, we're going to define the input shape, guys. Input underscore shape. Zooming it so much, I'm not able to see shit. Okay, is equals to, and then we are going to provide it with the shape of the one-dimensional matrix. To do that, it's just 1 comma nothing. Okay, that is the particular shape of a one-dimensional matrix, guys. 1 comma nothing. That's how you define the shape of a one-dimensional matrix. Are you guys able to get this? Please let me know. This is how you define the shape of a one-dimensional matrix, guys. Okay, 1 comma nothing, because again it has just one row. That's it. That is what we want to specify right over there. Okay, great. The next thing that we're going to do is we're going to add another layer, that is now the hidden layer, guys. Okay, so model dot add. How many neurons do we require in this particular layer? Can somebody let me know? How many neurons do we require in the hidden layer, guys? Can somebody let me know? I've already told you guys this. How many neurons is required in the hidden layer? 8. What is the activation function that we're going to put up in the hidden layer? Relu. And same regularizer we're going to put it in the hidden layer as well. So I'm just going to copy paste it. I don't want to write it again, so I'm just going to copy paste it. You just don't have to copy paste the particular input layer. Okay, you don't have to copy paste that just up till the regularizer, because that is just for the input layer itself. Just copy paste it right over here, and that's it. You are having your activation as relu, kernel regularizer as regularizers, and that's it. That is all that you have to do right over there, guys. Everything else you are having it input shape 1, so that is different. Okay, so that is just for the input layer. The last particular layer, guys, what is the last layer, and how many neurons are there in the last layer? Can somebody let me know? How many neurons are there in the last layer, guys? Can somebody let me know? And guys, I have made a very big error right over here, so I need to correct that as well. I'll let you guys know in a second. But yeah, how many neurons do we need to have in the last layer? 1. Very good. So I made a very big error right over here, guys. While defining the layer, I haven't defined what type of layer do I want. Model.add, I have added a layer, but what type of layer is it? I have not defined that in both the scenarios. That is my mistake, so let us correct that. The type of layer that we want to add is the dense layer, guys. The type of layer that we want to add is the dense layer, so DENSE, dense layer, right? So just put up a dense right over here, and at the end as well, we'll put up a particular parenthesis. We have to add a parenthesis right over here as well. And in the similar manner, we'll put up a parenthesis here, and we'll put dense right over here. We have to define that this is a dense layer. DENSE, dense. Okay, so this is also a dense layer right over there, guys. In a similar manner, we're going to add our output layer. So model.add, and it is going to be DENSE, dense layer. And it is going to have just one particular neuron inside of it. We're not specifying any kind of activation function because we want a linear activation function. By default, it is linear activation function, guys. This is linear activation function, guys. By default, the activation function is linear in dense neural networks. So we don't have to define the activation function in this. Just dense one is more than sufficient for our output layer, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know, guys. Now what we're going to do is we are going to compile our model together. So we have declared, okay, these are the different things. We have created the blueprint of our model. Now we're going to use Keras to compile that blueprint to create the model itself. We're going to compile that blueprint to create the model itself, guys. So that is model.compile. This will create the model itself for us, guys. Now we have to specify what is the optimizer and what is the error that we are going to use. So for the optimizer, we are going to use the Adam optimizer. We are going to use the Adam optimizer, guys. ADAM, Adam. If you guys remember the Adam optimizer. And for the error, for the loss itself, we're going to use the mean squared error. Okay. You guys remember the yesterday when we were talking about error, we had defined something called as the absolute error, and then that was like we took the absolute value of the error itself, and the second one we squared the error, right? So the squared error, a type of that error is called as mean squared error. Basically you take up the mean of the squared of the error. So basically what we were doing is we were just calculating the squares of the error and just adding them up. So it says that you calculate the mean of that. Instead of just adding it up, just divide it by the number of data points that you had. So you had an average error rate of your entire particular scenario. So we are going to use the squared error. Mostly people use squared error itself. It will enhance the error in most of the cases. That is the reason why we use square errors. What do I mean by enhance? So when you square a large number, it gives you a very large number. When you square a small number, it gives you a smaller number itself. So in that particular way, the larger errors make much more impact on your particular algorithm than the smaller errors. So that is the reason why most of the people use mean squared error instead of mean absolute error. Okay. So we are also going to do the same thing following the footsteps of the greats. Now we are going to create our data set. So we are not going to use any data set from outside. We're going to create our very own data set. So for that we need X and Y, right? We need the value of X and Y, guys. So for the value of X, what is the value of X that is going to be there? What is the value of X that is going to be there, guys? Some random numbers, right? The value of X is going to be some random numbers. So we are going to have a one-dimensional array of some random numbers itself, right? And Y would be some one-dimensional array of some random numbers squared. One-dimensional array of random numbers squared. Why random numbers? Because we don't want bias of any kind, right? We don't want bias of any kind. We don't want it to think like, okay, 0 has much more value than 1 or 1 has much more value than 2. So just some random errors that will make our data set much more better for an AI to learn from. Okay, randomness always helps. Okay, so let us do that. How to create a particular one-dimensional matrix of random errors. This is the code for that from numpy.random we are going to create a particular array of size 10,000 comma 1, that is 10,000 elements are there and only one row is there. Okay, 10,000. So you can use rand.random as well. I'm just using the full form random.random. That is up to you guys how you want to create it. If you guys know NumPy, it will be very easy for you guys. So this will create a random array, okay, of 10,000 elements. Okay, 10,000 elements itself. And what we want to do for it is that we want it to be multiplied. Okay, let me just put it up inside of parenthesis. Have I written the wrong spelling? Have I written the wrong spelling or something like that? Like, what is the scenario? Somebody's wrote random. I'm saying the same spelling. That's why I'm asking. See, my spelling is fucked up. Okay, in my job as well, I can type very fast, but I make so many spelling mistakes. There are so many errors in my coding. Okay, I have to work upon that. That is the reason I'm always a lot afraid that I've made some errors or something like that. Okay, so that is the reason why I always make sure that I'm not making any kind of errors right over there. Okay, it is okay. Let us see what this creates. Let me take this up. Code. Let me put it here. And let me just write X. Print X. Let's run this. Let's see what it creates. A name NP is not defined. Oh, I have to declare NP as well right over here. Import NumPy as NP. Okay. Now let's run this. Let's see what it creates. So it has created something, but it's the numbers that it has created, as you're able to see. The problem with np.random.random is that the numbers, it has created a particular matrix of 10,000 numbers. The only problem with these numbers is that these numbers are all in between 0 and 1. These numbers are all in between 0 and 1, guys. That's a big problem with this. Are you guys able to see this? Please let me know. It has created a one-dimensional matrix of 10,000 numbers, but all the numbers are in between 0 and 1. We don't want that, right? So we're going to multiply it by 100. I will rerun this. Now it has created a matrix of numbers between 1 and 99. Okay, 0 and 99. It has created a matrix of 10,000 numbers, decimal numbers itself, but 10,000 numbers between 1 and 99. Now, do we only want these in our data set, only the numbers that are positive? Do you want only the numbers that are positive? We don't want negative numbers? Then there is a bias right over there, clear bias in your data set. You haven't even considered negative numbers. Now, if you try to put negative numbers and predict it using your AI, your AI will fail because it has never seen negative numbers itself. So, you want to convert some of these numbers into negative numbers. How can we do that? We'll just minus it by 50. Simple. We'll subtract 50 from these numbers. So, some of these numbers that are between 0 and 50, they'll become negative. Some of the numbers that are in between 0 and 50, they will become negative, right? So, I run this. As you're able to see, we are getting negative numbers as well now. We're getting positive numbers as well. Are you guys able to understand? If you don't put negative numbers in your data set, then your AI has never seen negative numbers. What is the square of a negative number? Your AI does not even know. So you need that as well, right? So what we're going to do is we're going to go back. We're going to use this particular code now. I'm just going to replace the code right over here. X is equals to np.random.random 10,000 comma 1 and multiplied by 100 minus 50. Okay. Again, I'm very sorry. The next thing that we can do is y is equals to x square. So this is how you do square in Python. You just write 2 asterisks. That is how you will make the square of every single number that is present inside of the array. You will get another matrix, one-dimensional matrix with all the numbers ka square right over there. So to get the square of any number in your Python, you get do double asterisk right over there. One single asterisk means multiplication, double asterisk means to the power of. Okay, so now that is done. Shall we now we are going to fit the model, guys. Now we shit. Now we're going to go fit the model. We are going to take the compiled model. We're going to take the data. We're going to feed the data to the compiled model. We're going to feed the data to the compiled model, guys. It is actually pretty simple. So I'm just going to call it as hist is equals to and model dot fit. And to fit the data inside of our model, we have to take the x comma y. This is the input and the output. So as you're able to see, these are so many different things that it is showing. We are not going to use all, just the things that are important to us. X comma y. Now, okay. First of all, when you prepare for an exam, how do you prepare for an exam, guys? Let's come back to our previous example, right? The guidebook. You had a guidebook, right? It had questions and answers. Let's assume there are 100 questions and 100 answers in that guidebook. You are having a test. How would you prepare for that? First, you will take up some 80 questions and 80 answers from the guidebook. This is which you will use to prepare yourself, to learn. To learn right over there, right? This is like you are having all the access to the questions, all the access to the answers. You are going to learn from these 80 questions and 80 answers. Now, next what you're going to do is the remaining 20 questions and 20 answers. You're just going to keep the 20 questions. Okay. You're going to use it as a trial test. As a trial test. Before the final test, I'll give a trial test right over there to check if I have learned something or not. Before going to the real world and giving a test right over there, I'm going to do a trial testing on these 20 questions and I will write my own answers, A dash. I'll write my own answers, A dash. I'll compare it with the 20 answers that I already had. If I've scored above 15 marks, I've validated myself. I've validated myself that I'm ready for my final test. I am ready for my final test because these 20 questions I had never seen. These 20 questions I had never seen. Are you guys able to understand this? Please let me know. Are you guys able to understand these 20 questions I had never seen in my life? And I did 15. I scored 15 out of them. So I've validated myself and then I'm going to go into the final testing itself. There's a final test that is there in the real world. This is what we do with AI as well. Instead of training it on all the data, we create a small data set called as validation data set itself. So here also we are going to create a validation data set for our particular model to check if it is learning everything properly or not. Okay, so here we are going to call it as the validation data split. Split is equals to 0.2. That is from, if there are 100 data points, then 20 of those data points will be used to create the validation data set itself. I'm so sorry. Now come up the epochs. Okay. What do you mean by epochs? Epochs is how many times do you want the AI to go over the data set? How many times do you want the student to go over the guidebook? You have provided him with 100 questions and answers. But how many times do you want the student to actually read through those 100 questions and answers, guys? That is what it's called as epochs. How many times you want that data to your AI to go over your data set? So ideally you will put up a number right over here that is in thousands. At least 1000 or 1500 itself. But because we don't have enough time, I'm going to go over with 300 epochs. Okay. I'm going to go over with 300 epochs. When you are creating the project, when you are practicing it after the class, try to use at least 1000 or 1500 epochs itself. Epochs basically means how many times do you want your student, do you want your AI to go over the entire data set, to go over the entire guidebook itself. The more number of times that you study it, the more you will start remembering it, right? So that is epochs. Okay. And then batch size. $256. What do you mean by batch size? So at one seating, in one go, how many questions should a student learn before taking a break? For example, if I'm sitting right over here, I have 1000 questions that I have to prepare from in the guidebook. Will I sit and read all those 1000 questions at once? No, that is a very bad thing. I will randomly select 20 questions. I'll first learn them. I'll revise them. I'll give a test on it. And then I'll come back. Then I'll select next 20 questions. I'll learn them. And again, random 20 questions, not in the line. Random 20 questions I'm going to take up from the guidebook. Again, learn them and so on and so forth. I'm not going to take up 1000 questions at once. Otherwise, there's no point. So I take up random, small batches I will study. I won't study everything at once. I'll take up in small batches itself. Okay. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Yes. So let's try to run this. Let us try to create our very first AI. Let's see if there is any kind of error in that. So as you're able to see, we are having the epochs currently running. As you're able to see right over here, it should be completed in less than a minute or so. Okay. Let me do a calculation. So there is 10,000 data set that we have generated, right? 10,000 data set. And we have selected the batch size to be 256. We have selected the batch size to be 256. So this 32 out of 32 that you are able to see right over here, that is 32 batches that has been created. In each batch, there is 256 data points. In each batch, there is 256 data points that is there. There are 32 batches. So 32 times it is sitting and learning random 256 data points itself, random 256 questions itself, and is doing it 300 times. It is doing it 300 times itself. That is what this 32 out of 32 basically states. Now that your learning has been completed, let us see how well our unit has performed, how well our AI has performed, guys. So print model dot predict. So now our particular AI has learned what we wanted it to learn. Our AI has learned what we wanted it to learn. Now we're going to provide it with some data points to see how well it has learned. Okay. So I'm just going to provide some inputs and it is going to provide me some outputs right over there. Okay. So you are having, let's say, 2 minus 6, 36, let's say minus 88, 100. Okay. Some random numbers I have provided right over here. Let's see how well it provides us a particular solution with it. Let's run this. So it hasn't learned shit. Our model is working very bad. Like I said, the point being that we had to use at least more than 1000 epochs. Because our model is so small, it is not working correctly. So for 2 to the power 2, it is saying minus 19. For 6, minus 6 to the power 6, power 2, it is going minus 21 as the output. For 36 squared, it is showing 1378 as an output itself, and so on and so forth. So our model is actually not able to provide us a very good output. But if you guys go back and if you guys change the number of epochs to be above 1200, 1500 itself, it will start giving you a right particular answers. It will give you approximately the right answer, like 16 point something or something like that. Okay. So try it out, guys, today. Try out. Just change this particular part, guys. The number of epochs, change it to 1500 or 1200. And it will take you somewhere around, I think so, 5 to 10 minutes for it to run. And it will give you the right answers. I hope so. So I will change it right now. Let's see us at the end of the class if it completes running or not, because it is going to take us a lot of time. So even though I've changed it, as you're able to see, it is going to take us a lot of time. Every second it is doing somewhere around 5 or 10 particular numbers, 5 numbers itself. So it might take us a lot of time to get the final output. Let's see if it is able to complete it right over there. Okay. So guys, try to change that. Okay, number of epochs, and let me know if that is going to be come up. Name regularizer is not defined. Okay, most likely you haven't written this particular line of code. Keras, and it is regularizers. Okay, it is not regularizer, it is regularizers. Again, guys, plural, singular, please take care of these things, otherwise it is not going to work for you. Okay, small letters, capital letters, spellings, okay, plural, singular, everything should be the same. Otherwise, again, it is not going to work for you. Please remember that. In the meanwhile, I'll create you guys the attendance for today's class. Again, please do remember this. Make sure that you are practicing what we have learned in today's class. Otherwise, there is no point of attending the class itself. You guys should do something else in the meanwhile. Okay, in the meanwhile, I'll provide you guys with the attendance. I think so. This is day 4, right? Did you guys understand what we have done today, or have you guys not understood how what we have done today? Please let me know. Try to do it once on your own, and that will help you like understand the stuff a little bit better. Okay, so whatever we have done in today's class, try to do it on your own, guys. It will help you understand the stuff a little bit better. Okay, because without practicing, you will not be able to understand a lot of different things that we are trying to do. So try to practice as much as possible, guys. Okay, I'll give you guys the attendance in today's class, and yeah. The attendance link will be closed exactly at 9:24. Okay, the attendance link will be closed exactly at 9:24, guys. I provided you guys the attendance link in the live chat. You guys can start filling up the attendance. Again, guys, at 9:24 the attendance will be closed. Why there is less difference between epoch and batch size? Because like we didn't have time. You have to have the epochs to be as high as possible. Okay, that is, I have written 1500 right now. Okay, there's no correlation between batch size and epochs. Okay, again, guys, I'm not going to share the code. You have the accessibility to the video. You guys can watch the video to see the code itself. I've done each and every line of code. I've explained the code. The video is available with you guys with lifetime access. I'm not going to share the code. Then there's no point if I'm sharing the code itself. Okay, so watch the video. Try to do the coding on your own itself. That is what I'll be suggesting to you guys. Okay, so start filling up the attendance. As you're able to see, people have started filling up the attendance. The attendance link will be closed exactly at 9:24. In the meanwhile, I'll just check if this is working or not. So we are almost done. I think so it will take us like somewhere around 10 seconds more, 10-20 seconds more at max. We are almost done right over here. The 30 pokes more. Okay, so our training has been completed. Let us see if we are able to predict something or not. So the new model is also not able to predict things very accurately. For 2, it is giving me the answer as 15. For -6, it is giving me at least a correct, like positive answer, that is 24, but not the exact accurate answer. For 36, I'm getting 1264. Again, I don't think so that is accurate. Let me just check once. But yeah, you can try it out with different numbers, guys. You can try it out with different numbers. In some of the scenarios, you might be able to get something very close. So every computer has its own training data that is there. Okay, so for example, 36 multiplied by 36, that is 1296. So 36 multiplied by 36 is actually very close. This should be 1296. This is 1264. So that's come pretty close to what we wanted. 88 multiplied by 88 is coming up to be 7744. So that is way too far away. How to verify answer x square? Yeah, just do x square. Okay, you should be able to get it. Okay, guys, so try to do this. Okay, try to do this. Check up on changing the epochs. Okay, I think so we'll have to increase the epochs to at least 2000, 2500 itself. And yeah, testing path for better future. Do not go with testing. Most of the people who come to DevTown, they are from the testing background itself. They are like, I want to become a software engineer right now. Testing has no growth in it. That is the only problem that is there. No growth, very low salaries, and testing is one of the things that can easily be replaced by an AI. So do not go for testing. Okay, thank you so much, guys. We'll meet on tomorrow's class and we'll continue from right over there. Thank you, guys. Thank you. Bye bye. Bye bye. Bye bye.